The thing with fractions is that they are just numbers, and that means they have to behave in the same way that any other number does. So we've already seen how we can compare fractions in terms of size. That's us effectively working out where they would go on a number line. The other thing that numbers have to be able to do is we have to be able to work with them using those different operations, particularly the add, take, times, divide. And because fractions are just numbers, we also have to be able to add with fractions, take with fractions, times fractions, and divide fractions. Now the nice thing about adding and taking with fractions is that we kind of already have all of the tools in place to be able to do that. Let's think about some easier ones first of all. 1 out of 10 plus 3 out of 10. Well, the easiest way to explain what's going on here would be to draw a picture. Here is a box cut into 10 equal sized pieces. 5 on the top, 5 on the bottom. And first thing I'm going to do is I'm going to colour in 1 out of 10. I'm going to colour in one of those pieces. So there is the 1 out of 10. I'm going to label that as 1 out of 10. And then I'm going to colour in 3 of those pieces for the 3 out of 10. There's 1, 2, 3 for the 3 out of 10. Now looking at this all together, what we've got coloured in is 1, 2, 3, 4 out of 10. And that must then be our final answer. So we've got 1 piece out of 10, and we've added 3 pieces out of 10, and we've got 4 pieces out of 10. Now that one was reasonably easy to do because we were dealing with the same type of fraction all the way through. And we could extend that idea to look at some similar questions. 2 sevenths plus 3 sevenths, well that's 2 out of 7, plus 3 out of 7 will give us 5 out of 7. And 6 out of 9 plus 1 out of 9 would give us 7 out of 9. With the same kind of idea standing, you could always draw the pictures to prove that. We can think about subtracts in the same way as well. If we've got something like this one, 7 out of 10, take away 4 out of 10, well we've got 7 out of 10 to start with. So that's 1, 2, 3, 4, 5, 6, 7 out of 10 coloured in. But then we are taking away 4 out of the 10. We're taking away 4 tenths, so that's 1 tenth gone, 2, 3, 4 tenths gone. What are we left with? Still coloured in, 1, 2, 3 tenths left. And we could extend that idea again. You could draw the pictures to prove this to yourself, but if we've got something like 7 out of 8, take away 6 out of 8, that would leave you simply with 1 out of 8, 7 out of the 8 and 6 of them are gone. We've just got 1 left, and 4 out of 5 take away 2 out of 5 would leave you simply with 2 out of 5. 4 out of 5, and then 2 of them are being taken away to leave you with 2 of them left. Now it's particularly important to notice in these questions that the type of fraction in the questions and the type of fraction in the answer is not changing. When we had 7 out of 10 take away 4 out of 10, we were still left with an answer that was to do with tenths. Yes, when we're adding, the top numbers are being added together, and yes, when we're taking, the top numbers are being taken away from each other, but the bottom number is not changing. There are various different examples I can show you as to why that is the case. You might be wondering why we don't add the bottom numbers together as well, or why we don't take the bottom numbers as well. I can give you a very simple example of that. If I have a half plus a half, you know that what that is 1 whole one. 1 half plus 1 half, put those together, you get a whole. If it were the case that we add the top numbers and add the bottom numbers, again we don't, but if it was, we'd get 1 plus 1 is 2 on the top, 2 plus 2 on the bottom is 4, and we get 2 quarters. But we know from thinking about those equivalent fractions that 2 quarters is just the same as a half. And clearly, a half plus a half can't be a half. So this must be wrong. And the reason why it doesn't work for the taking away is because taking and adding, much like in all the other cases we've seen taking and adding, work very similarly. It's just that one of them is in one direction on the number line and one of them is in the other. So when we're adding or taking fractions, the top numbers will change, but the bottom number will stay the same, as long as they're the same type of fraction. But what if the fractions are different types? Work out the following and give your answer in its simplest form. So we've got an adding fractions question. And clearly we know that the bottom number is going to stay the same as it is in the question, except in this one, is the bottom number going to be 5 or 6, or in fact something else? To add fractions or take fractions successfully, we need to have both fractions with the same number on the bottom. They need to be the same type of fraction. It's a little bit like having pounds and dollars. If we had a pile of pound coins and a pile of dollar notes, we would be able to total up the pounds and we'd be able to total up the dollars. But the only way we could put those together is if they were both the same currency. If they were both pounds or both dollars or both something else. And that's the kind of line of thinking we need to take here. We've got two different currencies. We've got fifths and we've got sixths. To be able to put these together successfully, we either need them both to be fifths or both to be sixths or both something else. And that both something else is key. Because what that means we need to do is we need to rewrite one or both of these fractions to change them so that they are the same type of fraction. And how are we going to do that? Well, it's these equivalent fractions again. So what we're going to do is we're going to rewrite, in this case both of them, because there's no easy way to get from 5 to 6 or from 6 to 5, we're going to rewrite them both as equivalent fractions. And we're going to choose a number that we can easily turn 5 and 6 into. So we need something from the 5 times table that's also in the 6 times table. And a number that jumps out as being in the 5 and 6 times table would be 5 sixes are 30. So we're going to rewrite these two fractions one at a time to give us numbers that are out of 30 instead. So first I'm going to do the 3 fifths. And I'm going to ask myself, how have I got from 5 to 30 on the bottom? And to get from 5 to 30 on the bottom, I have timesed by 6. Now to keep these fractions equivalent, I also have to times by 6 on the top. And if I times by 6 on the top, then I get 3 times 6 is 18. And I get 18 out of 30. I've dealt with that fraction. We can now look at the other one. We can look at the 2 sixths. And we're going to try and rewrite this one so it's out of 30. So I ask, how have we got from 6 to 30? Well, to get from 6 to 30, we have times by 5. To keep the fractions equivalent, I have to do the same on the top, and I've done 2 times 5 on the top to get 10 out of 30. So we started with the question being 3 fifths plus 2 sixths. The question is now 18 out of 30 plus 10 out of 30, because we've just carried the plus sign down. And now we've got 18 out of 30 plus 10 out of 30. Well, that's going to be out of 30 for our answer because the answer isn't going to change. We've got 18 parts out of 30 plus 10 parts out of 30 is 28 parts out of 30. And that's 1 mark obtained, possibly 2 if they're feeling generous, 1 for the conversion and 1 for the answer. But then there's the final step in this question. We have to give our answer in the simplest form. This is quite a common part of these questions. And actually, it's going to be generally quite good form if when we're dealing with fractions, if we get an answer that is a fraction, we're going to rewrite it in the simplest form. More often than not, the question will ask us to do that. If they want us to, and you get into the habit of rewriting it in the simplest form for your answer, then you'll never forget, and you don't want to lose that mark. But if they're not asking for it, they'll just overlook it. So I would say always give the unsimplified answer and then simplify to the simplest form. So we're looking for something that both 28 and 30 will divide by. They're both even numbers, so we could divide them by 2 and get 14 on the top and 15 on the bottom. Is there anything that they will both divide by? Well, 15 will only divide by, well, if we ignore 1, 15 will divide by 15, which isn't much help to the 14, 3 and 5, neither of which 14 will divide by, so that is in fact the simplest form. And the answer there, 3 fifths plus 2 sixths, is 14 over 15. Work out the following and give your answer in the simplest form. 4 sevenths minus 1 third. Well, it's the same kind of thing again. Adding and taking work in the same kind of way. It's just one moves up and the other moves down. So what we need to do is we need to rewrite these two fractions so that they are the same type of thing. We can't easily get from 3 to 7 or from 7 to 3, so we're going to have to convert them to something else. It's a little bit like taking the pounds and the dollars and converting them both to euros, say. So we're going to rewrite them one at a time so that they are instead out of 21 will work. There's lots of different things that will work, but something in the 7 times table and the 3 times table, 21, 3 sevens will work. We want to deal with them one at a time. So the first thing we want to do is we want to convert the 4 sevenths, so it's out of 21 instead. We're going to look at the 4 out of 7 and we're going to work out what we've scaled it by to get the 21. So 7 to 21, we've times it by 3, which means we have to do exactly the same on the top, and we also have to times by 3. On the top then we're going to do 4 times 3, and that's going to give us 12, and we're going to get 12 out of 21 for our equivalent fraction. We're going to have a look at the second one now, the third, and we're going to rewrite that one out of 21. So we look at the 3 on the bottom and we ask what we've times by. Well, we've times by 7 on the bottom to get to 21. To keep them equivalent, we have to do exactly the same on the top. So we're going to do 1 times 7 on the top, and we're going to get 7. And 1/3 gets rewritten as 7 out of 21. The question was previously 4 sevenths minus 1/3. We've now rewritten the question, so it's 12 out of 21 minus 7 out of 21. We can do that. It's going to be out of 21 for our answer. 12 take away the 7 leaves us with 5 over 21. We need to write it in the simplest form. Well, is there anything that 5 and 21 will both divide by? No, there isn't. So actually that is already the simplest form. Does then beg the question of why that's there as part of the question? Well, because it depends which number you've used for the bottom of your fraction. If you'd used one of the other options, not 21, 42 for example, you might then have had to cancel down. Here, we already quite nicely had picked the number that gives us the simplest form, and 5 over 21 will do as an answer.